Hi, I'm Siloshan Brindesh, a student in Data Science and Artificial Intelligence MSc program from Faculty of Engineering, University of Moratuwa. Today I'm going to talk about MapReduce and Apache Spark framework. Today's agenda is I will describe you on what is MapReduce and what is Apache Spark, and I will show you a couple of key features of the MapReduce and the Apache Spark, and also then I will show you a live demo on how we can use MapReduce and Apache Spark frameworks in the Amazon EMR cluster. So let's move to the presentation. MapReduce is a programming and modeling of processing framework designed for processing large data set in a parallel and distributed manner. This framework was designed and developed by Google, and then it has been widely adopted in the big data industry. MapReduce is often used in conjunction with Hadoop distributed file system. And let's see a couple of key features of the MapReduce. MapReduce can handle large amount of data by distributing processing across multiple nodes in a cluster. Then MapReduce is designed to handle failures gracefully, and MapReduce distribute processing across multiple nodes in a cluster, which allow it to process large dataset quickly. And also MapReduce is a flexible framework that can be used to solve a wide range of problems. And also MapReduce abstract away much of a complexity of distributed computing, making it easy for developers to write parallel and distributed program. Finally, MapReduce uses parallel processing to perform computation on large dataset in a distributed manner. So these are the key features we can see in the MapReduce framework. Then we can talk about the Apache Spark. That's also an open source framework which is designed for big data processing. And also this framework was developed and designed by the University of California. Then after that, this is maintained by Apache Software Foundation. And Spark provides a unified processing engine for big data processing that support a wide range of workloads, including batch processing, real-time processing, machine learning, graph processing, and stream data. So let's see a couple of features. Spark is designed for speed and can process large dataset much faster than the other framework, and it is very easy to use, and Spark provides some APIs to call and do the development without any issue. And also unified engine. Spark has a very unified engine for processing batch, real-time, machine learning, graph, and stream data, making it unified engine. Spark provide a unified engine for processing batch, real-time, and machine learning, graph, and streaming data. And also a Spark designed to be fault tolerance and can recover from node failures without losing data or causing significant downtime. And also Spark can scale up or scale down very easily without any trouble. And finally, a Spark community supports to the developers and the end users to then and there to sort out their problem. So these are the key features we can see in the Apache Spark. So let's move for a live demo. So in this demo, I will show you how we can use Apache Spark and MapReduce function in the Amazon EMR cluster. So let's move to the live demo. So first I will show you how we can create a EMR cluster to work with MapReduce and Apache server. So first I have looked to my console, AWS console. Then I'm searching EMR here. Then you can go to the EMR page, and here you can see a couple of clusters I have created for my previous work. So for this demo purpose, I am creating a new cluster here. So here I'm giving a name like my cluster, like demo _1 or something. Then I am selecting the first application, this core Hadoop. So you can see there's the configuration of the application configuration here. So you can see it's a Hadoop framework. You can here, then you can see Hadoop. So we can use some HQL queries on this thing. Then I'm selecting here as a general purpose M3 X large. Then I will keep the by default setting without changing anything, and here I will choose my key. Then I am creating the cluster. It takes a couple of time. So until the cluster creates, I am go to my S3 because I wanted to load my data set to the S3. Here I am going to my bucket, then MapReduce here. So I am creating a one folder called live demo. Okay, so inside the live demo, okay, it's created. Then inside the live demo, I'll get a one folder called input data set or something. Okay. Okay, so I created one folder called input dataset. Now I have selected one dataset. This dataset contains around 1000 rows related to the flight details. I will show you while opening the CSV what are the content included in this CSV. So you can see there are a couple of 39 headers here, and also you can see around 1000 records here. This includes some sort of data which is related to the time frame, date, and flight delay, arrival time likewise. So I'm uploading this data set to the input directory. You can simply drag and drop here. Okay, so now I'm going to the EMR to check whether it's properly created or not before I go to. Okay, still status is saying still starting, so we can wait another couple of minutes. Okay, now you can see cluster has started already and waiting for the run the steps. So what I'm going to do next is I'm checking my security access to connect using SSH. So I'm going to the security access panel of master and slave nodes. Okay, so you can go to this and you can check whether I have SSH access. I guess, yeah, I already added that. If you are not seeing the SSH access, you can go to the inbound role, edit inbound role, and then you can enable the SSH access. Now I am clicking here to connect to the node. So host, okay, then the SSH here, connection, I put my key here, so click open. Okay, so I will click on accept. You can see. Okay, so I have successfully connected to the EMR cluster, and also I have created one table structure here. You can easily understand that this is I have created this from the HioQL coding. So I'm going to create an external table called delay flight. The table name is delay flight underscore Hio. Then I have put all the column name and the data type here, and also along with the creation of the table, I have had a small piece of code here to import the data directly from the S3. So I am just changing the S3 where I have uploaded already. So this is the place what I uploaded the CSV. I'm just okay, great. So I'm copy this piece of code here. Now I'm going to the SSH, then I'm typing Hive. So you can see, okay, so I log into the Hive, then I'm just checking like show databases, something like, let's see what are the databases available. Okay, so we can see a default database. So I will create one database, create database called like demo or something. Okay, it's created, then I will use that database, use demo. Okay, now I'm inside the demo database. Now I'm creating the table. Copy this and I will then paste here. Okay, so you can see now the data is importing. Okay, so you can see table has created, and the data which is in the S3 is already imported. So what we can do, ensure that, let's see let's check whether that all data is imported properly or not. So show tables, that's right. Yeah, okay, so we can see the table we have created, delayed flight Hive. Now I am going to check the number of rows in the selected database. Let's see, like count or something. Okay, so you can see the MapReduce is counting the number of rows in the table. It takes a little time. Okay, so you can see around 1000 data is available in the table. Let's execute couple of queries. So I have created couple of queries here. First I'm going to see the average of the carrier delays. So let's execute queries here to check what is the time is taking to execute the queries. Okay, so likewise, so you can check, you can run whatever the query you wanted to check, or what is the data what you wanted to extract from the table. So good, cool. So this is pretty much all regarding the MapReduce. So let's move to the Spark application, where I am going to the EMR cluster here. You can simply type EMR here, then and you can create one cluster. I will rename that as EMR underscore cluster underscore demo underscore 2 or something. And here I am selecting the Spark application, and here then I will select M3X large, then others I will keep as default. Then I'm selecting here the key. Okay, great. So I'm just creating, now I'm creating the cluster. Okay, the cluster has started now. So okay, now I'm going to connect to the Spark EMR. Then I am placing my host IP here. Then I'm loading my secret key. Okay, so then you can see I have successfully connected to the Spark EMR. So now I am going to the Spark shell mode. For that I am typing here, I am giving the command spark -shell. Let's wait a couple of minutes until load the Spark shell command. Okay, great. Now the Scala has loaded. Now I have some couple of queries. Okay. From the first query, I'm going to read the data I have uploaded in the S3 to for a one-off. I'm going to then load that, read and load that data to a one-off variable. Now I'm executing this query here. Okay, so it is now executing. Let's wait till complete the loading part. Is taking little time. You can see the process, the reading and loading part has started. I will assign a table name for the data frame what I created in the DF here. Okay, so it is run properly. Okay, now I will check the df.count here to check whether how many. Okay, so you can see 1000 records are in the df variable. Now I will try execute couple of queries here. Here you can see I have created one query to select to check the carrier delays of the data set and to show the data. Let's see, just copy and let's see whether how this is working. Okay, the score is running now. Okay, still running. Okay, so you can see now the data, extracted data based on the query what we have run here. But you can see even you see the data in the command mode, you cannot see the time taken from the to run the query. So for that I will I will get the Spark time variable. I will add the Spark time variable on top of the query, and let's see how it's work now. Okay, let's see. Okay, so now you can see the query has executed, and here you can see the query data, and also you can see the time taken to run the query. So likewise you can extract the data what you want from the using the Spark, and you can sort and you can manipulate any data using the Spark. This is the basic idea how you can use the Spark to get the data from the CSO or whatever the big data you have selected. Let's see a couple of comparison between MapReduce and the Apache Spark. From the ease of use, MapReduce usually providing a low-level programming language that the developers need write some code and data processing to get some data, but Spark provides some high-level programming languages which is developers too easy to get and extract and understand. And from the fast processing, Spark Apache is faster than the MapReduce, and in the other hand, Spark also provide a more efficient processing engine called resilient distributed data set, which allows for fast processing in iterative algorithms such as machine learning. As a summary, both MapReduce and the Apache Spark are useful for processing big data, but they differ in terms of ease of use and fast processing. MapReduce is a low-level programming model that can be challenged for inexperienced users, but can process larger datasets efficiently. In contrast, the Apache Spark provide a more accessible high-level programming interface, and it's in the memory processing and RDDS make it faster than the MapReduce. So this is the conclusion of the MapReduce and Apache Spark. Thank you.